All right, good morning, guys. Today we are going to talk about right triangle. So do you still remember what that is?
Yeah, all the angles they have two acute angles and one right angle.
Okay.
And
so
all of the angles for triangle, isn't it all the angles add up to 180?
Yeah. Well, what you said before was correct. Basically, right triangle is a triangle that has right angle. So what is right angle?
It's 90-degree angle.
90 degrees, very good. So if you plot right triangle, it'll be something like this. You see, no, you don't need to worry with that. Okay. So you see we have a right triangle here, and this angle is 90 degrees. Yeah. Now, I was wondering if you guys already know or heard about the story when the ancient Egyptian people built a pyramid. So you know that massive building in Egypt.
If it's not in the Bible, I don't know it. If it's about Egypt and it's not in the Bible, I don't know it.
Now, if you think about a pyramid, yeah, you know
it's made out of like four equilateral triangles and one square.
Yes. So basically, if you look at the base of
square-based pyramid
of a pyramid, the base of that, this, yeah, it is a square.
Square.
And what happens is if you have a square, the angle that you have here, no, I'm talking about the angle here, is 90 degrees.
Times 4.
Okay. So the question is, how did they know, or how did they get this 90 degrees? Or how did they get this 90 degrees? Remember in the time when those Egyptian people built the pyramid, they did not have, you know, protractors. So there is no
I think I know.
tool. Yeah.
The sun? Did they use the sun?
What do you think, Patrick? You don't know, okay.
I'm guessing sun.
No, actually, you know what? There are two big hypotheses. So you know what hypothesis means?
Yes, good guess.
Good guess. So the first one was they tried to get like a very long rope. Okay. So this is the way they get this 90 degrees, because remember at that time they did not have protractor. Okay. So they got the long rope. For example, this is the rope. Okay. And you know, now they divide the rope into 12, divide into 12 equal length. And this is not difficult actually, because you can use like a small stick or stone, yeah, and then just tie it here. So this is one section. Okay. Now we have another section. This is the second one. Okay. So they want to have now 12 sections. So we have what? 4, and then 5.
You got to play.
6, yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, oops,
10.
And then 12. Now, do you know what they will do with this rope?
They, I don't know, cube has like 12 like sides or something.
So let's say this is the starting point. Let me just call it A. Yeah, and then this is the final point. Let me just call it B. Okay. Now you try to connect those points, basically. You try to connect those points and make a right triangle from it. So what happens is when you have 12 equal length sections like this, they will need first 3 sections and then 4, and then the rest that you have is 5.
Is that like a coincidence?
No, because they know exactly with this rope. So let me now make it a right triangle from this here. So you see, we have 4 here, and then you have 3, and then you have the other one, which is the rest. Okay. Or in this case, actually, I want to have first 3 sections. So the first one is 3. And then the second one, it's 4 right there. And then the last one is 5. So basically, this is where A and B will meet. Okay. And in between, you have 12 sections, remember? So this is section 1, this one, you know, and then this is section 2. Okay. Actually, you know what? You can try to make this later if you want, you know, so you have a long rope and then divide that rope into 12 equal length sections and then create a right triangle from it. So we have 12 equal length section here. And what they see here is that the angle that they got, this angle, is exactly 90 degrees. So when they put this triangle on like a surface or something, yeah, like on the, you know, land, it makes 90 degrees. And they got that angle, 90 degrees. So that's very smart, actually. Remember, at that time, they did not have, you know, the protractor. Now, the second hypothesis that we have is like this. So we use the same rope, yeah. Now, you know what? Actually, if you have, let's say, a straight line, yeah, let's just call it point A and B again. Now, do you know the angle that you get when you have a straight line?
180.
180.
And they just halve that?
They halve that. They
just
halve it.
move the thing. So it's like, it was like
No,
this.
but the question is how they can divide this angle 180 into 2 equal angles.
They decided to move it up.
Yeah, but they cannot just move it up. You know, there's something that gives them this right angle.
The
right?
horizon or something?
No. So let me make it a bit smaller. Yeah. You know, if you have that straight line again, yeah. So for example, this is the straight line. And the point A and B are located at the end of the line, yeah. Now, you want to divide this line into 2 equal angles, okay? So what you can do is you can create like a compass using a rope, okay? So the other end, you put like a needle or maybe a nail, and then the other one also a nail. So this is to make sure that you will now put on this one, and then you try to make like a circle, you know, because if you have used the compass, you know, you can create a circle. So this is from this one, yeah, and then you move this nail to the other end. Yeah, so basically you bring this point to there and then create another circle.
Oh yeah,
So,
you told me this before.
yeah, basically, you know, when these two circle intersects at this point and this point, yeah, when these two circle intersect at this point and this point, and then you connect these 2 points.
Yeah.
So you see, basically it also divides. So this line is dividing the AB line into the same angle, yeah, which is 90 degrees.
That's like a shape that starts with a.
So that's actually a very smart idea when you look at again those people in the ancient time, because they know how to create this interesting angle using this kind of knowledge. Okay. Now, I want to go back to the first method that probably they use here. Yeah. So if you look at the triangle we have here, yeah, let me now draw it again in the other page. So you see, we have that triangle before that the length here is 3 unit. You know, you can measure 1, 2, 3, okay, and then the other length here is 4. Yeah, and then the other length here is 5. Okay. So let's say this is 3 centimeters. This is 4 centimeters, and this is 5. Now, when you square them, okay, let's just square 3. What is 3 square?
That's 9.
So Patrick, how do we square something?
I think it's like based on the sides.
No, I mean, what is 3 square means?
The area.
No, we are not talking about the area of a square yet, but what I'm asking is this mathematical calculation. When you have 3 square, what does it mean? So this is just mathematical notation, 3 and then to the power of 2. That simply means 3 times
3 because
3.
there's 2 things.
Remember?
Oh,
Yeah,
is 3 times
that
3,
is called
and
3
times
square, right? 3
Oh.
square is 3 times 3. So
Yes.
that is 9. Now, when you look at the second one and then you square it, yeah, what is 4 square? So 4 square means 4 times 4. Remember?
Yep.
Yeah. So what is 4 times 4? 16. The last one that we will square it is 5. So what is now 5 square? So 5 square, what is that? 5 times, very good. So yes, that's 25, okay? Now guys, look at this. If you look at these numbers, yeah, 9, 16, and then 25, actually they are connected by a simple rule. Can you see that? What is the connection between this, among these numbers? You know, 9, 16, and 25. What?
No, wait. 7,
Mm-hmm.
and then, no. I thought it was going to be 7.
No. Can you create a mathematical expression which includes these 3 numbers? So you can have addition, or you can have multiplication or subtraction, whatever. Basically, it has to include these numbers.
9 and 16 is 25.
You agree with him? So he said that when you add 9 and 16, yeah, it makes 25. That's correct. Okay, that's correct. Now let's look at again the origin of these numbers. Yeah. So remember what 9? It was 3 square, and then 16 was 4 square. Okay, and then 25 was 5 square. Yeah.
But that
now,
makes 50. That makes 50 if you add all of them together. 9, 16, 25, and 50.
No. So 3 square was 9, right? 4 square was 16.
Yeah.
And then 5 square was 25.
Yeah.
So what I'm showing you here is, if you look at again the sides of that triangle, yeah, 3, 4, 5. So basically, there is a connection between these numbers, and it comes to this simple rule where you square this guy 3, and then you square this guy 4, and then you add them, give you
5 squares.
this square. Now, I think if you already know this simple rule, what do you call it?
Wait, is it the formula for triangle?
Yeah, that's the formula for right triangle. Now, do you know the exact name for it?
No, right now what it is, it's half base times height.
No, I'm not discussing the area yet at the moment. So what I'm asking you is, if you look at this simple mathematics rule, yeah,
Base,
that 3 square plus
times-
4 square equals to the 5 square, yeah. You know the name of this simple formula?
I feel like I'm going to take a while.
Okay.
Quadratic.
No,
equation.
no, that is called Pythagoras.
Yeah, how are we supposed to know that?
Oh, maybe you haven't heard this before, yeah, in the school.
I may be in the year 6 class, but we haven't
Okay,
heard anything.
so
like that.
this simple mathematics rule, which connects the sides of right triangle, yeah,
Is it a name of a guy from
it's
Greece?
called Pythagoras Formula. Okay,
Is
so
it a name of the guy from Greece?
yes, he is from Greece.
Knew it. Isn't that the guy that made the Library of Alexandria?
Actually, I don't know about that, yeah. But maybe you are correct. I don't know.
It's a
But this is actually quite interesting, because when everyone sees the formula of
Patagoras.
right triangle, yeah, they will remember this famous formula that we call it Pythagoras Formula. So now let me tell you, actually, before Pythagoras discovered this formula, a lot of people around the world before him, yeah, like 1,000 years before him, yeah, they already know. In fact, I already told you, when these Egyptian people, they built the pyramid, they know already the you know, there is a connection between those sides, yeah, among those sides that makes this simple formula. So basically, all of those ancient people, yeah, from Egypt and then China, and maybe in the Middle East, yeah, they already know actually about this formula long before Pythagoras. But what I told you was, I don't know why until now we call it, yeah, he got the credit. He got the credit, okay?
We should call it the Egyptian
Yeah.
formula.
So basically, the Pythagoras formula says like this: if you have a right triangle, you know what? If you have a right triangle, and then let's just have the sides here equal to A, and then the sides here equal to B, and then the side here equal to C. Now, based on this example that we had before, where you have a right triangle that has a side 3, 4, 5, and then they make 3 square plus 4 square equals to 5 square. So now look at this right triangle that we have here. And what I give you now is more general. Oh, okay. So do you agree that the Pythagoras formula for this right triangle give you A plus B equals to C?
Yep. I think.
No, see, when you just have A plus B plus C, now look at this number. If you add them, 3 plus 4.
Oh no, A squared plus B squared equals C squared.
Yeah, that's the correct one actually. So you can't say that A plus B equals to C, because when you look at the example that we had before, they make 7. So it can't be just A plus B plus C, A plus B equals to C. But the right one will be A square plus B square equals to C square. So this is the famous Pythagoras formula.
The credit.
Yeah.
Guy.
Now, remember, what A and B are, actually they are these sides. Yeah. And C here, it's the longest side. Or do you know the name of that actually? What do you call the name for the longest?
This slope.
No, actually we call it hypotenuse.
I wasn't calling the thing the slope. I was saying, oh, is it
Yeah.
the slope you're talking about?
Mhm.
But I would never have gotten hypotenuse, so it didn't matter.
But okay, let's not worry about this name if you haven't heard about it before, because well, it's just a name at the moment, okay? But what I'm trying to show you again is like this, that there is a simple rule that connects the sides of a right triangle, which is if you add the square of the sides here and here, A and B, this equal to the square of the longest one.
Is
Okay.
that a coincidence?
No, that's always happened. So there are many proof actually about this simple rule. Yeah, there are many proofs that you can find later. But I think you will learn about this Pythagoras formula very soon. Yeah. Now let me give you another example. Yes. So let's say I have a right triangle like this. You know, I have a right triangle. Yeah. And let me just give you so for example, I have a right triangle that has the length. Oh, actually it is quite difficult. Let me just draw it like this. So okay, I have a right triangle. Yeah, look guys, this is the last one. This is the 90 degrees angle here. Okay. So my question is, if I have this length which is equal to 5, and then this length equal to 12, now what is this length? C.
165. Yeah.
No.
100.
No. Now you need to calculate actually.
Oh goodness. 165 divided by.
How did you get 165?
5 times 5 squared is 25. 12 squared is 144. Oh wait, I did something wrong. It's 169. Wait. Yeah, I'm correct. It's 169. No, but we gotta find out what.
Yeah,
this
that length.
is.
So the calculation was correct, but
It's
then
169, but we need to find what the original length was. Wait, do we need a cube? Not cube it. What was the opposite to square it?
yeah, you square it.
What's the opposite to it? You don't square it. You do the opposite.
You take the square root now. You take the square root.
Oh yes, square root.
You remember the square root of.
We just divide it until. Yeah, I guess you can until the lowest. I feel like that's inefficient, but.
So what is square root of 169? Now think about this. 169 is actually not quite big number, you know. In fact, you already squared 12, which is 144.
Oh yes, wait. Do you just add 5 onto the 12?
No.
I'm gonna try it anyways.
Yeah, try to get the number. So Patrick, do you know when you square this guy, C? So basically what you have is like this, right? According to that formula, A square plus B square equals to C square. Yeah? Now you put that number here, 5 square, and then 12 square, which gives you 25 and 144. So 169, yeah, okay, very good. Now that 169 is equal to what? To C square. So C square, when you square C, it gives you 169. Now, That means C is equal to the square root of 169.
Oh yes, I remember a way of doing this.
Now,
Wait,
what is the square root of 169?
I don't know.
So
wait, what's 13 by 13? That's 9. And 1. It's 4. And... Ah, no, that's 179.
careful, calculate one more time, 13 by 13.
Wait. Times 13. $39. I got it. It's 13. Square
So
root 169 is 13.
very good. It's
Oh,
13, yeah? It's 13. So
Oh my God.
you know what? If you wanna do this Pythagoras formula, yeah, I will suggest, if you can get some of the square number bigger than 10, yeah, bigger than 10 square, which is 100. For example, what is 11 square?
11 by 11. 110.
No, that's 11 by 11.
1
to 1.
Oh yes.
And you already told about 12 square, which is 144. And then this one, 13 square, it's 169. Yeah. Now, what I was saying to you, if you can get maybe up to 20, for example, yeah, 14 square, that is 14 by 14, and that is 196. And then what is 15 square? That's 15 by 15. That is 225. So if you can, well, I would say remember some of these square number, that will be great, Well, of course, you need to know how to get this number, right? For example, 16 square, which means 16 times 16. So if you calculate this, you will get 56. But my point is, if you already know about this stuff, that 16 square is 256, that will be great, Yeah. And then, for example, the next one, 17 times.
256 seems like an important number.
Yeah, because you know what? Sometimes you will see this square number quite often. That's why I think, yeah, if you know some of them by now, yeah, maybe from 11 to 12, they'll be good, okay? So I'll get you some other exercise after this, yes?